Hi, everyone. Hi, Steve. Nice to have you here.
Hello, Katrina.
Hi, hi.
How are you
So,
doing?
hi, all, and welcome to Memgraph Community Call. Today, we have Steeve Bete from Orbic talking about how they built a secure multi-tenant GraphQL API on top of Memgraph. I think the presentation will really be awesome, and I'm looking forward to it. But before we start, just a couple of notes on the Livestorm options we have here. So there is chat below, questions and polls. So please use chat for general conversation. If you have questions for Steve, please post them in the question section. And don't forget to check the poll section to answer questions that Mata will be posting from Memgraph. After the presentation, we will do a short Q&A where I can read your questions out loud so Steve can answer them. And yeah, I think that's it. And I think it's enough of me talking. So I'll leave the stage to Steve. And everyone, please enjoy the presentation.
Wonderful introduction. Thank you.
Thank you. Thank you.
So I'm going to share my screen right now. And so can you see the slides?
Yeah, everything looks amazing, Steve.
All right, let's get started. So thanks everyone for joining this call. We are going to talk about how we built a secure GraphQL API on top of Memgraph. So a little bit about myself. I'm Steeve Bete. I'm a senior software engineer. I'm based in Cotonou, Benin. In my free time, I used to powerlift, which is a strength sport. But now I enjoy gardening, even though I'm not that great at it, as you can tell by the state of my bell peppers. I wasn't able to save them from a virus. But for my defense, they actually it's actually not as easy as programming. You need more patience when you change things. You have to wait for nature, this kind of thing. So yeah. Anyway, I'm much better at Ruby and JavaScript, which are the main languages we use at Orbit. And I joined Orbit 2 years ago. We help their businesses grow the community and get closer to the customers. We actually have a fully fledged community platform with integration on like Discord, Slack, these sort of places. And we give the community builders all the tools they need to know what's happening and take action. So in this talk, I'm going to go over why and how at Orbit we came to use Memgraph, how and why we built a GraphQL API on top of it, and the security challenges we have to overcome. All right, let's dive in with why we use Memgraph. So as I said, we are a community platform. So we deal with a lot of community data. And the main assertion we use are activities and members. Activities are usually a form of message, like these are things that happen in the community. It could be a comment on a GitHub issue, a Stack Overflow answer, a Discord message, a Slack message, these kind of things. And members are the actors of these activities. Okay, so we have a lot of members and activities, but they are not actually standalone entities. They're actually deeply connected and form what we call the community graph. So once you connect activities, they form conversations, and then members interact through these conversations. So everything is interconnected. So it's really the need to explore and navigate this community graph that led us to graph databases and more specifically Memgraph. It was easy to install and use, fast. It has a very friendly lab. And talking about the lab, it actually allows us to see the overall schema of our database. So at the center here, you have a project that represents the community, and it owns several nodes, such as the member, conversation, and activities, and they're all interconnected. So I think it's going to be a bit more clear with some examples, queries. The first one is how you will get, for instance, a few conversations from the graph database. So you will start from the project, making sure to target a specific one like here with the name Sally, and then you'll get conversations that are included in that project, like owned by the project. You can add some sorting and pagination, limit the result to just 2, and then you will include the activities and members that are related to the conversations. And there you get this beautiful graph view offered by Memgraph Lab. where you have the conversation that includes one activity and is performed by the member, just like we asked. And here you have a conversation that includes two activities, but they are performed by the same members. And you can already tell that it's probably a member that replied to their own message or something like that. So, right, so that's the first example. The second one is one that you will use, for instance, to get, at least as far as my local data set is concerned, the members that interacted with me at some point. So you will still go from the project, making sure to target a specific one named Sally, and then you will grab the member that represent myself, as defined here by the handle. And then you will get all the members that message me at some point. And then you get this beautiful graph view still with like my member that is connected to the member with whom I interacted at some point. A little bit of a disclaimer, you won't get the same profile picture on your Memgraph Lab, so just beware. Okay, so the more we played with Memgraph and Cypher in general, the more we liked it, and we decided to take it seriously and build an API server on top of it. We actually wanted to interact with the community graph from other apps, like our main products, but also give access to developers, like our users that for a long time wanted to understand these interactions and these kind of things, curious people. And the natural API we found to build on top of a graph database like Memgraph is GraphQL. Like, because of the rich connections between the entities, you need something that's graph-like, and GraphQL is the perfect candidate for that. So how did we build our GraphQL API? Okay, we started from a node server running Fastify, which is a low overhead server. It's like a modern Express.js, for those who know Express. And then the goal was to leverage Apollo, which is a common solution for serving GraphQL servers, like GraphQL APIs, and then running that server through the integration with Fastify. But now we needed a glue layer between Apollo that runs GraphQL and Memgraph. And thankfully, Memgraph is fully compatible with Neo4j GraphQL that knows how to translate Cypher queries, GraphQL queries down to Cypher queries. In terms of code, you start by feeding the type definition and resolvers to the constructor of Neo4j GraphQL that knows how to compile it down to a fully functional schema that can be fed to Apollo server. And from there, you can start the server and plug everything with Fastify. And voila, you have an API that you can query. And yeah, so you remember how we were able to get the conversations with Cypher? We can actually do that with GraphQL as well. So you will start by still the project, making sure the name is the one we need. And then you will ask for the conversations that are included. With the options argument here, you can specify the same sorting and pagination. And then you will ask for activities that are included and then members. And you get the result you ask for. And that's really good about GraphQL is you get exactly what you ask for. And here I ask for project, I get project. Ask for conversation, I get the conversion under the project. Ask for the specific last activity item, I get it. I get the activities, and I get nested members in this same format. And this is really great for like developers that want to explore things, especially with the fact that we can now secure the API. Like, we could have given access directly to Memgraph, but that would be much harder to secure. But with an API, it's much easier to add a security layer on top for this kind of application. So the good thing with Neo4j GraphQL, it gives us like a powerful tool to deal with security, like enforce it. Clients will authenticate with a JSON Web Token, and like in the authorization field header, you will have authorization, bearer, and then your token. And the token is a signed JSON, okay, that has standard fields like standard claims, like the subject, which is usually an ID, the expiration timestamp, the issued at timestamp, and other custom claims that you can add as needed. Here we have roles. So what Neo4j GraphQL gives you is a powerful directive to match the structure of your token with the data on your graph. And here, for instance, we have the authorization one that allows us to do this match. So the first thing we need to do is define the custom claims here in the type. The standard ones are automatically supported, but the custom claims, you have to define them. So once this is done, you can apply the directive. And here we are just going to make sure that the ID of the node, which represents the current user, matches the subfield of the token. And we can also check if the admin role is included. So basically, it's like an admin token for a specific user. Okay. So this example is taken from the documentation of Neo4j GraphQL, and is the tool we have to enforce security. Right. So now we are going to see how this tool can help us solve our specific needs. So the first concern we have is isolation. As I've shown previously, at the center, you have the project that owns a lot of different nodes. So here I displayed the projects and a few connected nodes, and you can really see that you can draw a circle around isolated clusters. So each cluster will represent a unique community, different community, and what we want is to be able to issue tokens that are constrained to specific clusters. Right? We want, for instance, to have a token that can only access this community but not others. Okay. To put that a little bit into perspective, let's take this example. We have Alice here that owns a home cooked food community, Chuck that owns a fast food community. Alice has her token to access her community, and Chuck has his token to access his community. Okay, so far so good. But you can already tell that Alice and Chuck are not the best friend, right? Alice was able to convince a few people from Chuck community to join her community by talking about like the joy of cooking at home, the smell of the kitchen, these nice things. And Chuck is not happy about that, not at all. So what Chuck would really like is to use his token to discover the members that are about to join Alice community and win them back with like ads or like juicy offers, these kind of things. And yeah, if Chuck is able to use his token, he will be able to get the members and get what he wants. And of course, we don't want that. We don't want that. So we are going to find a way to protect Alice from Chuck. Right. So the question is, where do we apply these GWT rules to protect Alice from Chuck in this scenario? If you're not careful when designing your GraphQL API, people might be able to just access every single node, like members activity. They might be able to list out all the members across communities, like across any project, and all the activities as well, and gain knowledge like that. And if you want to secure things in that scenario, you will have to add the rules on every single node. And this becomes quickly tedious and a lot of work, and you are more prone to errors like that. So we don't want that. We want to simplify things. Okay. And what will make things really simple is to make it so that the only way to access the data is through projects, so that we only have to secure the project. It's like not having to worry about closing all the rooms of your apartment, but only the front door. It's much simpler. So in order to achieve that, we have to make sure that the project is actually the only gate. And to get there, what we are going to do is disallow any operation like reads, writes on other nodes like members activities. And we are only going to allow it for the project. Okay. So if you're able to access the project, then you can access the other data like members activities, but you have to go through that gate. Okay, so the project is the only gate and you have to go through that gate. With that configuration, it's much simpler. Like you only have to add the security rule to the project node and not all the other one. And that's how our JSON Web Token rule looks like for the project. I really want here to draw your attention to here. We are basically checking if the project ID of the token matches the ID of the project here, okay? Of course, as admin, we reserve like more privileges to access our data, but developers will get something like that, where the ID, the project ID of the token must match the ID of the project to go through. And once they go through that, they can access the members, the activities, and so on. So with that, Alice will have a token with the ID of her community. Chuck will have a token with the ID of his community, and he won't be able to use his token to get the data to read Alice's community because the ID don't match. And yeah, we're able to protect Alice, and that's 1-0 for Alice. Okay, now we have a second concern. We want to separate read from write. Basically, having tokens that can only perform read and then token that can write. To put that a bit into context, like why it's an issue, if the owner of a workspace agrees, we can make the community data public. Okay, so we actually have a product called Community Search that makes the data searchable by the public. You will add the community search widget to any website, like your documentation website, and people should be capable of typing search queries to find hidden knowledge in the conversations. A lot of things are in the conversations, and being able to find them like that is something the community search offers. Okay, so now let's say that Alice found that there's so much more value to open her graph community, like her community graph, so that people can get value from it, like knowing interesting recipes, food hacks, and these kind of things. And she goes on and deploy community search. This event will make Chuck really happy because now he has another idea, a comeback idea. I'm going to take Alice public key used by the community search, use the key not to read because he can already read, but to override all the messages with ads of free burger delivery, these kind of things, to try and win back some members again. He doesn't want to give up. But of course, we are still united against Chuck. And yeah, we want to protect Alice once more. In order to do that, we have to understand how we write. So we actually leverage custom resolvers. So custom resolvers are akin to virtual nodes, so to speak, that are connected to types. So here I have a custom resolver that is attached to projects, but I have a custom resolver that is attached to conversations. Usually, once in the GraphQL query, somebody hits a custom resolver, is going to execute a callback, and then in this callback, you can run more complex code and logic, usually to perform some aggregations and these kind of queries. But it can also be used for writes, and we do use them for writes. The issue with that is you cannot apply security rules here. So once people have access to the main gate, they have a free way to the resolvers. And no matter how deep the resolver are, if they have access to the main gates, it's just a free way. So this is an issue we need to solve. We can't let these resolvers in this access tree because people will be able to access them. So we have to remove them from this access tree. We have to remove the resolvers on there. Otherwise, Chuck will just be able to go through and execute his plan. So, but somehow we still need a way to manage writes, okay? But we need to do that in a secure fashion. The first step to get there is to create new types that maps back to the same nodes. So the types in your GraphQL schema are like pointers to labels and nodes in your graph database, and you can actually duplicate the pointers, provided you name them differently. So by default, the name of the project maps to the label of the nodes, but you can actually have a different name that maps to the same thing, as long as you use the directive node labels here. And the same way, for project, we also have like, we can also define new mutable types for conversations, a new mutable conversation that maps to the same conversation node. So now we have the ability to construct another access tree. So we can now have another access tree that is mutable project and all the other mutable types, and now move the resolvers to this access tree. If the resolvers are located in this access tree, we still have to secure them by adding the GWT rule. But the difference here is that we will ask explicitly to have a write scope in your token. Otherwise, you won't be able to go through the mutable type and then access the custom resolvers. So to recap a little bit, you have two accessories, a read accessory and a write accessory. If you want to read the data and know what are the latest activities conversation, you go to the read accessory. But if you want to access the resolvers, you go to the write accessory. And this gives us the ability to issue read-only token that can only read the accessory, but cannot access the write tree. And yeah, so with that, the public key that is used by community search will be read-only. And no matter how hard Chuck will try, he won't be able to execute his plan. And that's checkmate for Chuck. So yeah, we're able to squash our main issues with isolation and now separating read and write. We are going to recap a little bit. The first thing we do is define the GWT type with the project ID, the scopes, and then we are going to use the type that we define to enforce the authorization rule on the project, making sure that you have to have the project ID to read this node. And once you can get through that rule, you can have access to activities and conversation members. This takes care of the isolation bit. And we are going to have another tree, the mutable project, that maps to the same project level. And we are going to have another rule, making sure that the token has to have a write scope. And once you get through this filter, you can now access other mutable types. And yeah, from there, we can add now the resolvers to the mutable types. So here we have these two resolvers on the mutable project, and we have other resolvers on the mutable conversation one. And effectively, we have two accessories that separate the reads and the writes. Okay, so this is how we're able to overcome our security challenges. The first one being isolation, and the second one being read and write, by just having separate accessories. The good thing about this solution, what we really like about it, is we can push it and think beyond and use it to solve even more complex access rules. Let's say, for instance, that we wanted to have a tree from which you can only, let's say, read members, and another tree from which you can only read the activities. What do? We just define more accessories. So the first one would be like a member-only type, for instance, that maps to the project, but only includes the relationship to members. And the other one would be the activity-only project that only includes the activities connection. And then you can have the type that includes everything and have separate rules to keep them separated. So yeah, it's a solution that can really accommodate a lot of complex scenarios. And yeah, so next time you have a similar security challenge with GraphQL, these kind of things, I hope this is really helpful. And yeah, thanks for listening.
Thank you, Steve. This was really awesome. I've been reading comments in the chat. I think really good comments. I think you can be happy. Everyone is saying thank you and are really excited. And they all said, like, you have an awesome presentation style. So I think that really nice and kind words from the chat there. I think it was really great and fun. So yeah, to start off, maybe I can ask you a question. Was it hard to use Memgraph with GraphQL from Neo4j, and did you have to make some specific adjustments? How did that process go from your side?
Yeah, this is a good question. At first, in the earlier version, it was a bit hard because we had to modify the container to include some mappings. But in later versions, it just works out of the box. You include your Neo4j setup, Neo4j GraphQL setup, and it works just fine. So yeah.
Yeah, we did made some improvements there recently, and I think that's the reason for that. But of course, with your help and everyone's feedback from the community, I think that work was so much easier. So thank you all for that, of course. Do you also have any tips and tricks on what to look for when using Memgraph with GraphQL and in general? Like, did you find something useful for the community?
Yeah, so the first thing to keep in mind when dealing with GraphQL is that it forces you to have a schema. You can use Memgraph without the concept of schema because it's not like a relational database where you have a fixed structure. But GraphQL forces you to think in terms of schema. So you need to take some time to think about your needs, the requirements, and really design something that is stable. And um, yeah, I also think still with the schema, at some point you might experiment, you might have some data drift because the schema is expecting something and then your data isn't up to speed with the schema. So first of all, you need to define, if you can, a schema that is generic enough. So for us, we use properties. Like we wanted, for instance, to support a lot of additional fields down the way related to the project. But instead of having them already listed in the project, we connected another node called project property, where you can have a name and a value, basically. So this allows you to have more fields coming your way without having to change the schema. And now, if you can do that, something that is generic and stable, you have to think about some way to implement migration. We actually rolled a simple solution, simple in terms of size, to manage our migration, basically running Cypher queries to update the data so that it matches the schema. Like if people are interested, we can maybe plug that out and share it with the community. So.
Yeah, that sounds really awesome. We have a lot of community members asking about those stuff like migration, so I think it's really useful, and everything that you developed so far is really great.
Yeah.
We have another question. Yeah, Steve, go. Did you want to add
Yeah,
something?
I have more tips.
Yeah, oh, that's amazing. You go.
So another one is getting really comfortable with the Apollo dashboard. There is a lot of interesting things that you get out of the box with Neo4j GraphQL, and just taking the time to explore with the Apollo dashboard can give you ideas and simplify some queries you might have in mind. Another thing is getting comfortable with the Memgraph Lab, because if you want to use resolvers, for instance, to implement complex queries and these kind of things, having the lab is a good place to try out your queries and improve performance.
Yeah, that's a really good tip in general. I think that Memgraph Lab really eases the process of working with Memgraph in general, and it's really good to try it out and see what you can do with it. So we have. Do you have more tips on that side? I don't want to. I don't want
Yeah, I
to
can
go
keep
with other
going, but
questions.
I can keep going, but we can take other questions.
I think you have a lot of tips based on the amount of work you've done here. But yeah, the next question is from Soren. So he asks, how long does a single GraphQL request take? Is it like 100 milliseconds? Is it like 50 milliseconds? Can you give some kind of scale there?
Yeah, I found it's around 50. more closer to 50 than 1. Of course, using GraphQL is not as fast as Cypher because to translate the GraphQL queries down to Cypher in a generic fashion, you have to make some compromise, and this affects a little bit performance, but not. It's not a deal breaker usually.
Okay, yeah,
It's still really fast. I think the most you lost, like the most time spent, is during network calls.
Yeah, definitely, yeah. And we have another question. So the question is, what features do you feel like are missing from Memgraph? I'm also interested in this one. Like, which feature do you feel like should be there and would like to see in Memgraph next?
Okay, for Memgraph itself, I'm not sure, but maybe things around Memgraph, like maybe like a migration system, it will have saved us some time. The Memgraph Lab is awesome, and I think it's. I saw something just recently. You added a graph chat, able to query with natural language. This is tremendous.
Yeah.
So yeah, I think there's still more things we can do on the Memgraph Lab side to make it even more awesome. But yeah, Memgraph itself has been pretty good, especially the fast aspects. Like being able to execute queries that take less than a millisecond is incredible.
Happy to hear that. But yeah, like for any feature request you might have or anyone else, we have everything on GitHub publicly available so anyone can open an issue. And yeah, looking forward to everyone's feedback on that side. And we have another question. So how big is the Memgraph database that you are working with?
Okay, so we ported only a fraction of our data from the main products to analyze and play with the community graph. But it's around, the last time I checked, it was around 1 million nodes and 4 million edges. So it's sizable, but you can grow further than that.
Yeah, that's a nice size. And have you ever tried like other graph databases, or did you jump straight in with Memgraph? Like, what was
Yeah,
your...
we just jumped straight with Memgraph, and we haven't found a reason to leave.
Okay, I don't quite understand this question from Christoph. Is this like, was this supposed to be like a license issue or license? I don't know. It's like there is a bit of typo maybe, so I'm not sure. So just license, okay. Yeah, just to clarify, like Memgraph is compatible with Neo4j GraphQL because of the Bolt protocol. They are both supported, so we just connect that way. Steve is using the community version of Memgraph, which is open source, so I believe there are no issues there.
I think I saw another question in the chat, from
let's see.
the graph value is that you can always add from Bassam.
Yeah, the Bassam was wondering, like, he questions the value of GraphQL when using Memgraph. Like,
Yeah.
what are your views?
Yeah, obviously, like I said, the GraphQL forces you to think in terms of schema, and it's a trade-off. For us, it was the sensible choice to make, because if you want to give access to people, having an API with a security layer is something you have to have. So, but also it's GraphQL itself, okay, it's fun to use, like writing queries and so on. So it's easier for people to explore your data like that, especially when using Apollo. So it has a lot of value, even if it has a drawback. So it's always a trade-off.
Yeah, definitely it is. And yeah, I don't see more questions coming in, but I have another one maybe to wrap this up if there won't be any other questions. So can you tell me a bit more about the community search that you mentioned? I am very familiar with the Orbit. We have been using it internally in Memgraph, and it's been such a wonderful tool for us. So yeah, can you share more about the community search? What did you learn while you build it? And yeah, tell
Yeah,
us more.
yeah, yeah. Thanks for the question. So for us, community search, we view it as the missing piece of the regular doc search. So it's common to find developer documentation sites a doc search, being able to quickly find your page and navigate through the documentation. But actually, a lot of interesting knowledge is buried in the conversations, uh, whether they are happening on Discord or GitHub and so on. So being able to excavate all this knowledge and put that in front of people is something really interesting. We actually have that deployed on our own documentation site. So I will type that in the chat if you want to use it. So from there, you should be able to try and see for yourself how it looks like. And one interesting thing we learn with that is also how to play with LLMs. It's actually really interesting. Like we use LLM. The first thing we use LLM for was for moderation, like removing inappropriate conversations that are not adding a lot of value, some ranking. We are developing also assistants that knows how to use the knowledge from many places to answer your questions. So being able to having the opportunity to work with LLMs is something really fun, especially these times. So yeah.
That's really cool. Yeah. And we have additional question here, probably related to the stuff you were mentioning on community search. So Bassam asks further to the search, what did you use for text search? How about searching multi-language text? How did you somehow resolve that?
Full text search, you mean?
Probably, yeah. Like, what did you do to have like a performant text search in the
Yeah,
community search
yeah, okay.
tool?
The,
Yeah.
the, the thing we did, we used Memgraph to consolidate and structure the data to understand like this activity relates to this activity, person or this member, these kind of things. And once we have the right structure that is formed, we use a search database on top of it, TypeSense, to index things and enable full text search. And yeah, TypeSense is also something that is super interesting. And yeah, that's what we did.
Yeah, that's a really good question from Bassam, and it really shows how you can use different kinds of tools to kind of achieve what you want. And on this community search things, like I really love it from the developer experience side of things. I think it's quite hard to have like one source of knowledge and then give everything to the users. And I feel like it's really good that it collects like different sources of truth, let's call it like that, and then
Yeah,
anyone can search and find the answers. And I feel like it's a really cool tool. And with the advantages of AI in the future, it will be like, I think it will be
yeah,
even better and better.
yeah, totally.
Cool. So if no one else has any additional questions, Steve, do you want to tell anything more? Do you want to share something else, or is that it?
Yeah, just really enjoy talking here. So if people are still interested, I could share at some point our like migration system, and maybe what else? Yeah. So, or maybe even get another talk to talk more about LLMs or anything that people are interested in.
Yeah, definitely. We can do this not once, but many times again. You were a really great presenter, and thank you so much for joining. Like everyone else is also thanking you, and I feel like everyone enjoyed this. Yeah, thank you all others for joining. You will all receive the recording after this event, as well as the presentation that Steve had. And if anyone has additional questions, feel free to join our Discord server. Steve, if you're not there, join. I'm not sure. So if anyone has questions, they can ask you directly as well.
Awesome.
And yeah, I think that's basically it. Hope to see you all soon. Thank you again, Steve, and everyone. Enjoy your evening or day, morning, whatever.
Yeah. Thanks you so much for having me, and thanks everyone for joining. See you soon.
See you next time. Bye.
Bye.